Hello everybody and welcome back. We're going to be looking at how to do permutations with restrictions, which is a huge variety of questions we get asked within this topic, and there's so many ways we can restrict our permutations questions. The logic stays the same for all the questions, and combinatorics as a topic is a topic in logic. So the first restriction we are going to put in is we are given the word isolate. We are asked how many arrangements of the word isolate both begin and end in a vowel. So the way we're going to solve this is we are going to use our boxes. I have 1, 2, 3, 4, 5, 6, 7 letters in the word isolate. So I'm going to draw my underlines here. I've got 1, 2, 3, 4, 5, 6, 7 letters that I'm trying to arrange and figure out how many different arrangements I have. Now, if this was without restrictions, it would just be 7 factorial. 7 ways to pick the first, then 6, then 5, then 4, then 3, then 2, then 1, just like the last example. However, because it has to begin and end in a vowel, I want to first take note of how many vowels do I have. Well, my vowels are I, O, A, and E. So I've got 4 different vowels in the word isolate. If my word has to begin with a vowel, that means I only have 4 choices to make for my first letter. If it's going to end in a vowel, well, I've already picked one of the vowels to start the word with, so now I only have 3 choices here at the end. Now, if I was to flip it, put 4 choices at the back, then I'd also only have 3 choices at the start. Either way, I end up multiplying 4 times 3 or 3 times 4. Both options give the same answer of 12. So either way I kind of think of it, I think it's easier to start from the beginning, then work our way to the end. So we're going to begin with 4 choices for the first letter, 3 choices for the final letter. So hopefully that part made sense, okay? 4 ways to choose my first letter, 3 ways to choose my second. So now, I'm just left with figuring out what goes here in the middle. Now, 2 of my vowels are taken. Let's just say for argument's sake, it is the I and the O are both taken. So I've got 1, 2. If my non-vowels, that is 3, 4, 5 letters left. So I have 5 ways to choose my next letter. Then I have 4 ways to choose, then 3 ways to choose, then 2 ways to choose, and then 1 way to choose my final letter. So again, I'm going to be multiplying all of these different terms together. So what I wind up with is, essentially in the middle bit here, if we can see, I've got 5 factorial in the center here. This part here could be rewritten as 5 factorial, and then I have multiplied by 4 and multiplied by 3. Now, because it's multiplying, I can kind of choose whatever order I like. So I'm personally going to do it as 4 times 3 multiplied by 5 factorial. This maybe could be considered a calculator question. We actually did 5 factorial in the last example. 5 times 4 gives 20, times 3 gives 60, times another 2 gives 120. So we've got 120. 120 times 4 is going to give 480. And then 480 times 3 is going to give what? That's 1440, I believe is the answer. Yes, I feel pretty confident there. I get an answer of 1440 for part A. I should just write here, this is part A. So if you keep the vowels together, 4 ways to pick the first letter, 3 ways to pick the last letter. I have 5 letters left to choose from, 5 options, 4 options, 3 options, 2 options, 1, and I've got all my different arrangements covered. Okay, so I've tucked part A up in the corner. For part B, you can see I've got my vowels of I, O, A, and E, and I have my remaining letters of S, L, and T. Now, if we are keeping the vowels together, what this means is that we are going to be kind of treating the vowels as one individual group, which means when I'm arranging my letters, I only really have, in a question like this, I've got 4 different groups because my vowels are going to all stay together as one group. So to figure out how many ways I can arrange them, I could have, well, I could pick all the vowels as one group to go first, or I could pick letters S, L, or T. I've got 4 ways to pick my first letter. Then I've got 3 ways to pick my second, then 2 ways, and then 1 way to choose how I want to group all of my vowels plus my 3 remaining letters. Now, this becomes 4 factorial. Okay, we can see that it equals 4 factorial. That's 4 times 3 times 2 times 1. However, where this question gets a little bit tricky and why people sometimes struggle with when we start kind of grouping or collecting our terms is I can also arrange the letters I, O, A, E 4 factorial ways as well. So to help explain that part a little bit more, we're just going to focus on these 4 letters. And if you just look at the vowels, well, I've got 4 different vowels. I could pick any letter to go first. Then I could have 3 choices for the second letter, 2 choices, then 1 choice, which is also going to equal 4 factorial. So what my answer becomes is simply 4 factorial multiplied by 4 factorial. 4 factorial is 24, so I have 24 times 24, that is going to give 576 as my answer for all of the arrangements if I keep the vowels grouped together. Okay? Where people struggle with combinatorics is the logic. It's not as nice a method, in my opinion, as solving algebraic questions where I can apply opposites and it's a very structured approach. There is a structure, but a lot of this is going to be case by case, read the question, group the terms, and really we're just thinking about what happens if I collect or I think about how my arrangements work. This idea of creating groups, these little underlines, I think is the best way in terms of getting a really, like trying to get as structured an approach as we can to how we can solve some of these permutations problems. And again, a lot of this comes down to factorial notation as well. So hopefully you guys found that helpful, and I'll see you guys in the next video.